Welcome to Domain and Range. Today we are going to use our understanding of function notation as it relates to domain and range. We will evaluate functions for inputs in their domain and determine theoretical and practical domain and range. In this diagram here, we can see that our domain is our input. These are our x values. And our range is always our output or our y values. Notice right here we have function notation, f of x. That means that f is a function of x. X is our input, which gets us our output f. Let's look at a first example. Let's examine domain and range in this problem. Consider this equation. This equation says I of p is equal to p times the quantity of 50 minus p. This gives the expected income in dollars from a bungee jump attraction when the ticket price is $P. So we have the expected income given a ticket price. Pause the video for a second and think about what this equation means to you. All right, expected income. That's I right here. The ticket price, that's P. So given a certain ticket price in this equation, we're going to make a certain amount of money from the bungee jump. Say you're the business owner. You want to know how much income you're going to make based on different ticket prices. So, is I a function of P? Can you explain why or why not? Once again, pause the video and see if you can come up with the answer. Remember from our previous lesson that a function is a function if we have an input that has exactly one output. So in this problem, if we put in a price, we should only get one income. We should not get two. And this makes sense. So if we want to explain why or why not, we would then say that, yes, because for each ticket price, there will be a different income. How about B? What does I of 10 equal 400 tell us about the bungee attraction? Again, pause the video and think about that to yourself. Well, this means that for an input of 10, we're getting an output of 400. The input 10 is our domain, and the output 400 is our range for that value. So for a ticket price of $10, we're gaining income of 400. Let's put it into the equation and see how this works. So here's our input 10. I've plugged that in for P in both of these places. Now let's solve this. So for a ticket price of 10, we would have 10 times 40, 50 minus 10 is 40, and then we would have 10 times 40, which is 400. Consider your order of operations. Parentheses comes before multiplication. So what we know about this is that if we charge a ticket price of 10, we will have an income of 400. Okay, what are the theoretical domain and range of this function? Well, what does theoretical mean? Theoretical is compared to practical down here. Theoretical just means the math version. What happens if it's not in context? Mathematically, what is the domain and range of the function? How do we figure that out? Well, remember that we talked about domain and range before. Domain is here along the x-axis. That's our domain. And then our range is vertical, up here and potentially down here along our y-axis. So we want to know mathematically, what is the domain and range of this function? How do we answer that? What we have to then say to ourselves is, what input can we plug into this domain and still get an output? Well, I could plug any number theoretically in for P, including negative numbers. So I could plug things all the way from negative infinity way out here, all the way to positive infinity way out here, and I would still get an answer mathematically. May not always make sense, but I would say that all real numbers are my domain, and therefore all real numbers will also be the range. How about practically? What makes sense practically? Well, given this equation, what type of input can I have? Well, if we think about it in terms of ticket price, we know that people will pay anywhere from $0 all the way up to some amount. The question is going to be, what's the maximum amount they're going to pay before our income actually starts to drop down because we have less and less people buying a ticket for our bungee jump? Well, if we look at our equation, what happens if we plug a 0 in for P? So if we pay $0 for a ticket, then we would have 0 times 50 minus 0. Well, that just gives us an income of 0. So I guess that's reasonable if we don't want to make any money or have any income. But at what point can we go up here in price and still make money? Well, let's look at this. 50 minus P. Well, at some point this is going to become 0, and then we would have 0 income again. Well, if we change this and say that we have a ticket price of $50, 50 minus 50 is 0, and 0 times 50 would still give us 0. So we know then that our domain, our practical domain, is probably going to be somewhere between $50 and $0. So if we charge $0 for a ticket price, we won't make anything. And if we charge $50, we're also not going to make anything. How does that work? It's fairly strange. But we're going to look at a graph in a minute to help display that. How about the range? Well, the range is going to be a function of our ticket price. Because remember that income, which is our range, depends on the price. I could take and I could plug numbers into this equation and figure out our range, but sometimes an easier way to think about range is by looking at a graph. Here is a graph of that function. Notice that it is a quadratic, it is a parabola. It's not straight, it's not linear, meaning we don't have a constant rate of change as we move up. Notice that down here for a ticket price of 0, we have no income. Also notice over here for a ticket price of 50, we also have no income, which is what we discovered already looking at the equation. Now what about this point up here? This is our maximum income that we can make, and it looks like it's right around $625. So what we want to know is, at what ticket price can we earn this maximum amount of $625? And we can just look down here to see it's probably around $25. Notice that as we increase the ticket price beyond that, our income actually starts to drop back down because we don't have as many people buying tickets anymore. So let's determine our range from here. Well, our range is going to be anywhere from 0 income all the way up to 625. So we know that it's going to go from 0 greater than or equal to 0 all the way up to 625 less than or equal to 625. So that can be verified by our graph. Let's look at one final problem. In this problem, we have an athletic shoe company, and they estimate that its production costs for a new model endorsed by a star athlete will be a function of the number of pairs of shoes that it makes. Again, pause the video. Think about what that means. What it means is that depending upon how many shoes they make, the production costs, which is our C of X here, will be affected. It'll change depending upon the number of shoes. And here is the rule that relates the cost to the number of pairs of shoes. All we want to do now is use our function notation to help us solve these problems. So we want to calculate and explain the meaning of C of 1, C of a million, C of 2.5 million, and the value of X, for which C of X is equal to 40. Pause the video, see if you can calculate that, and think about what that means. For the first one, we're just plugging in this 1 as an input here in our domain. Well, 25 million divided by 1 is still 25 million. And 25 million plus 29 is going to be equal to 25 million and 29. For B, now we have 1 million. So we're going to make 1 million pairs of shoes. Our cost production cost up here per pair of shoes is going to change dramatically. We have 25 million divided by 1 million. If we get rid of these zeros, 25 divided by 1 is 25, and 25 plus 29 is just going to be 54. So our cost per pair of shoes went down dramatically. So why is this happening? Why is our cost per production of a pair of shoes going down the more pairs of shoes that we make? Well, if you think about it, we have a lot of fixed overhead costs like rent and employee salaries and things like that. The more shoes, the more pairs of shoes we make, the more that cost is being spread out over those shoes, and it's going down. For our last one, we want to know the value of x, for which c of x equals 40. Again, pause the video, think about what this means, and try to make an estimate. Well, what we're looking for, what does this 40 represent, is actually the production cost per pair of shoes. And we know it's going to be somewhere between 1 million and 2.5 million shoes, maybe closer to the 1 million. But how can we then find this algebraically? Well, here's our equation. What we're saying is we need for our cost per shoe to equal 40. We calculated what it equaled on the other ones, but now we know what we want it to equal. So let's take our equation. What are we trying to find in our equation? We're trying to find x. So we would need to take this equation and solve for x. In order to do that, we would need to isolate x or make it be by itself on this side of the equation. So we would get rid of this 29, or in other words, move it to the other side by subtracting it from both sides. Once we do that, we're left with 11 over here. This cancels out. 29 minus 29 is 0, and we get 25 million over x. At this point, we can just cross multiply. 11 times x is 11x, and 1 times 25 million is 25 million. Finally, if we take the 25 million and divide by 11, and the reason I'm dividing by 11 is because I need to eliminate it from the left side. That would be 11. 11 divided by 11 is 1, so I'm left with 1x equal to this amount. This then would be how many pairs of shoes I would need to produce in order to get a cost per shoe of $40. And as you can see, 2.2 million approximately is between the 1 million and the 2.5 million. And this concludes our lesson today on domain and range as it relates to function notation.